Hi guys, hope everyone is doing well. You can see I am not videoing this at 2 a.m. so hopefully I do not sound tired and worn out and whatever else. So first thing is, if you have not finished your online homework, then do that. Okay, I did not look at it today. I think I checked again yesterday and Friday. No new assignments submitted. Sadness. Okay, only a handful of y'all have done that. That was before we went out on break and all this crazy stuff happened. So those are in there as zeros. So you need to make sure you get that done. All right, now this distance learning thing. I know there was stuff on your portal, distance learning. I looked at that. I think I was in the high school one though, which was not what you guys saw. So if you're doing that, that's great. I didn't take anything from there so that you wouldn't be repeating yourself. I just went and, did lessons like we normally would do with the whole pathway thing. So I don't think this is a big deal for us. We've been doing it this way for quite a while now. You watch video, do a reflection, do some practice. I'm just not there with you, which is sad because I do miss you guys a lot. But if you need help, you can email me. A couple of you emailed me all year, and I will get back to you as soon as possible. I'm going to be checking email specifically between 10 a.m. and 12 p.m., although I do have some conference calls with the other 8th grade teachers, and we have faculty meetings and things like that are going to kind of pop up in those times. But I will answer you as soon as possible, but not after 9 p.m. So do not, you can email me at 10 o'clock if you want, but I'm not going to answer you till the next day. Okay, so you can do Google Hangouts. I will respond to you there. I don't usually, but I learned how to use that, so that's cool. Or you can just email me or comment on anything in the classroom, which brings me to comments in the classroom. Please make sure they're appropriate and you know who I'm talking to. Okay? So just think about what you're going to say before you say it. Alrighty? That's all I'm going to say about that. Okay, so we are going to go to we're going to start our quadratics unit. Sorry. And so before we start that, we're going to go back and review domain and range. Because the domain and range, we did linear functions and we did quadratic functions and we did some exponential stuff back in the beginning of the year. But we do need to review it now. So that's what this video is going to do. And then you're going to have some practice. So just follow the classroom. You don't have to do it like Monday and you have to get this done and Tuesday you have to get this done. It doesn't really matter. I'm just giving you the week. I gave you suggestions. If you want to work a little bit every day, this is how I would break it up. But if you want to do like algebra on Monday, Wednesday, Friday, and some other class Tuesday and Thursday, that's fine. I just gave you like the week. I would like it done, by Monday if you can. Okay, so that we stay on track. Okay, so do what you can do. If it's a problem and you're having issues, just email me. This is new for everybody really, so we can be super flexible. Not like we aren't all the time anyway. Okay, so I think that covers anything. If you have questions, then email me. Right now, you're going to need to get out your notes. Journal would be great, but I think it's worth writing some of these things down. Now, of course, you have the video, and I did make slides, so you don't have to constantly try to be reading my handwriting. So you'll always have that to refer to if you need to. Okay, so let's go to the next slide. Okay, so we're going to talk about domain and range of quadratic functions. So quadratic functions, here's some real world examples, roller coasters and arches, and here's someone shooting a basketball, and you're going to do that little activity a little bit later. So quadratic functions come up all over the place in the real world. Launching a rocket, throwing a football, diving into a pool, anything that kind of makes that U shape, it's called a parabola, that's a quadratic function, okay? And the last chapter that we did together, we were factoring trinomials. For the most part, those were quadratic. Okay, so let's move on. All right, so quadratic functions are functions. Oops, sorry, I was trying to get rid of my side. There we go. Quadratic functions are functions in the form f of x, ax squared plus bx plus c. So it's quadratic when you see that power of 2, and it graphs as a parabola. Parabola is the curve that has that U shape, and it could be a U that opens up, like in this one, upward, or it could open downward like this one. Okay, so again, the trinomials we worked on factoring the last time we were together were quadratic, and then here's some examples of parabolas. Okay. Okay, so your learning target is by the end of all of this work, you're going to be able to write the domain and the range of quadratic functions using inequalities. When giving a graph or a piece of a graph, the quadratic unit, a lot of times they will give you the graph, and if not, and you're looking for some things and you're like, boy, I really could do this if I had a graph, then you know you have your graphing calculator. I did link for you a link so that you could get some TI free trial for 60 days of the TI software that will look just like the calculators we use at school. The iPad app is there, or iPhone, and then also if you have a PC. I'm not sure if it'll work with a Chromebook, so try it and let me know. If not, we always have Desmos, and you can use Desmos for graphing. Okay, so to review, domain and range. Domain is all the possible x values of a function. The range is all the possible y values. So I like this graphic that I found on Handy Dandy Interweb because it does what we did when we talked about this. We talked about finding the minimum and maximum values for x and y, and that's how we figured out what inequality to write, okay? Most of the time, that when they have a beginning and an end kind of thing here, we're going to write the variable that the domain or the range goes with. So domain, remember, x, and then the range is the y. So we write that, and then we write on either side the inequality signs. Now, remember, if you have closed circles, it's also equal to. Okay, and these both have closed circles. If it has an open circle like this, say, then that one's closed in, that one would just be a less than sign. This would just be less than. Okay, and then you just get your values here. So what's my smallest x value? What's my largest x value? The domain, like we said, is kind of like beginning and end of your graph as you're reading left to right. That will work. And we did a thing back in October, so when we talked about this, where a Desmos thing, it kind of squished the graph to the x-axis. That's what you kind of want to do, okay? All right, and I can't write this because we don't have numbers, but that's okay. Now, the range, remember again, and I think this is where minimum and maximum comes in really handy, because the range is not necessarily where the y's start and end. It's the smallest up to the largest value. So if you go where the graph begins and ends, you're going to pick that for your range value, and that's not correct. All right, so as far as open circle, closed circles go, every point on this line is a closed circle. So you're going to do y less than, in this case, equal to, less than or equal to, because these are all closed, okay? So again, you're taking that curve or graph or whatever, and you're kind of squishing it to the y-axis to see how much space it's going to take up there, where it's going to be the smallest or beginning, and where it's going to be the largest, okay? All right, so let's see what's next. Okay, so I figured might as well talk about this here, and we'll talk a little bit more about this later on in the week. Quadratic functions that are not bound by real-world situations. They're just random functions out in the world. You have this x squared plus 2x plus 1, and they say graph it, okay? So if there's no real-life situation, then it doesn't matter what x and y are. Remember, when we have real-life situations, we a lot of times do a graph over time. Well, time can't be negative, so that puts a restriction on your domain, okay? If they're not bound by real-world situations, the domain is going to be all real numbers, because it won't matter what your equation looks like. You can put, let's see, I think this is x squared minus 2. You can put anything in there for x, minus x squared minus 2. You put anything in there for x, and you're going to get a y value out, okay? So when you see this, your domain is going to be all real numbers, okay? And that, I would say, is true. I hate to say always, because, you know, there's always that one situation. For the most part, in Algebra 1, that's going to be true unless you have a real-world situation tied to it, okay? All right, so that's the domain for both of these, all real numbers. Okay, and I switched the colors. I usually do the domain in red, or I mean blue, sorry. But let's talk about the range. So this graph opens downward and it has a maximum point of -2. So then the range here would be y less than or equal. Okay, so the range, y is less than or equal to -2. Okay, because it's everything under this. Okay, there's my maximum point and it goes on. I know you don't always see the arrows on here, but you just assume they're there because when you graph in Desmos is where I did these, it's going to cut them off when you snip it. Okay, now over here, again, my domain is all real numbers, but my range, oh my goodness, I can't see. -2 again. So my range this time, I have a minimum point. So that means my range is everything above there. So my range here is going to be y is greater than or equal to -2. Okay, and remember, if this is a line, that means that point is colored in, it's not opened. Okay? All right, so that being said, what you're going to work on next. Okay, so the practice you guys are going to do are all tied to real world situations. Okay, so they could have a specific domain and range like this one. This is a height and a springboard, so this looks like I'm going to go with somebody diving. That's what I think. I don't know, maybe it's gymnastics. I don't know. But I'm given the height on the y-axis and the distance from a springboard on the x-axis. Okay, so if I am looking for my domain, I see that I don't have any negative distances. That's not a thing. So my smallest x value is 0, and it's colored in there. And so is this one, and it goes to 8 is my largest. So that's my domain. And then my range is my y value. So the smallest y value here is 0 when they hit this springboard. Maybe they're jumping, I don't know. I don't know why you jump onto a springboard, because that would probably send you flying again in the other direction. But anyhow, so my lowest y value is 0, and my highest is up here in between 22 and 24. So I'm going to call it 23. Well, to 23. Okay, because that's where the maximum point is. The minimum point is, so that's my range right there. Okay? All right, so I think that's our last slide. Yes, it is. All right, so you're going to do next a Nearpod. There's a couple of slides in there to give you some review notes, but you're basically doing a matching. So you're going to match them up, and then you're just going to interpret a little bit. Okay, and then there's a Google form practice that came from the same document, again, multiple choice. And then you have a little Desmos thing to do. Okay, and that'll review our domain and range. We already did it, you just thought we should review it before we go on to our next topic in quadratics. Okay, let me know if you have questions.